So welcome everyone. I don't know if this is working. This is great. So in the next 55 minutes or so, we are going to have a session about clinical and well-being applications of the metaverse. So we have with us Antoine.
Yes.
Thank you. Patricia Pons. Yes. And Bernhard. I don't know, sorry if I pronounced wrong. What we are going to do, we are going to have presentations, each of those around 15 minutes, and then you are welcome to, of course, ask any question and tell anything you want.
Okay, thank you. So I'm here today to discuss about our new project that we started like in April. So the name is IPC4MH, for Immersive Prevention Center for Mental Health. And this is founded by the THCS initiative in Europe. So it's a transforming health and care system. And on the 2024 call, they had a call about secondary and tertiary prevention in Europe. And we succeeded to have one of the projects accepted. So what we want to solve in our project is the mental health issue, as the title says. And we are more interested in two populations that are, in our case, vulnerable. And the first one is the adolescents with neurodevelopmental disorder. We know that autism is a big issue in Europe, in the world, and it's difficult to get diagnosis and to get treatment because there are a lot of people and not enough practitioners. And the second group that we selected was for the older adults. And we know that after retirement, we don't use the brain as we used to during the work activity. And we are more like pushed aside of the society. So we are at risk of depressions. And so what we would like to solve in our project is to remove the barriers that are there that are for the mental health people like that are suffering from mental health. So we have stigma, professional shortage, and geographical access. For me, I live in the mountains area of Switzerland, and you have to take 2 hours of train to go to the nearest university hospital. So why cannot we do something better, proactive, inclusive, and scalable intervention? So, sorry. Sorry. So the consortium is, we have 6 partners. 2 come from Switzerland, 3 from France, and 1 from Poland. So I am the coordinator of the project. I'm coming from the University of Applied Sciences, Rotterdam, Switzerland, and French part of Switzerland. And this consortium has public and private partners. We have Diversity, which is a startup in Switzerland that does mixed reality game for home-based exercise for teenagers, and it's really close to what we will see next, the next speaker. So I won't talk too much about this. In France, we have Nantes University with Yannick, who is in the room today. We have the University Hospital of Nantes. We have C2 Care, which is a SME active in virtual reality game for mental health. So they have, if you buy the Pico headset, you have the C2 Care application in it. And in Poland, we have the Institute of Psychology of in Warsaw. So why do we use university technology? I mean, in this room, I think everyone will agree with me saying that we have event-based VR application for cognitive training, for exposure therapy. We all went on the bench, on the board, and having a skyscraper in the VR headset, and we were like feeling like really like was height and rehabilitation. So we all agree on that. And what we would like to add to that is the metaverse aspect. So having a persistent shared interactive spaces that we can go whenever we want, and it's always open. We don't need to have an app that we do, and we don't need to have like meetings in there. And the IPC4MH project builds upon like 2 types of projects. The commercially available product as C2 Care and Diversity has already. And we use techniques as well, like Yannick had a lot of experience in teleclinic with waiting rooms and one-to-one meetings. So we based our project on this aspect. So we have a focus on prevention because the code was about secondary and tertiary prevention. Primary, it was not something that we wanted to do. The primary is to avoid getting sick. So if I talk about lung cancer, it's like I don't need to smoke. And secondary is early detection and intervention. So the idea is that you have already symptoms, and we want to know if you are at risk or if you already had the disease. And the tertiary prevention is about preventing deterioration of known condition, meaning that we want to keep you as healthy as possible, and we want to give you exercises that prevents the worsening of your symptom. So, for example, for adolescents, is the VR social skills that we can do, and early screening for autism or ADHD. For other adults, we have cognitive game because we know after the retirement you do less cognition, less cognitive tasks. So we need to get the brain working, and as well like mood is a big factor in the older people, and social as well. So the project objectives are as follow. We would like to design and validate these immersion prevention centers, and we would like to see if you can actually embed them in the metaverse, like accessible from anywhere, anytime. And for now, what we do is we co-design these prevention centers with clinicians, researchers, and users. And we will have pilot sites in Switzerland, France, and Poland, so we can see how it works among like multiple countries in Europe. So the idea of the project is not to see if it's effective, it's more to see if it's visible or if it's actually needed or if it's actually like welcome by the population. So it's not like we won't treat people with this, we want to know if it works. So we have 3 phases in the project. So we are currently in the first phase. So co-design and prototyping. So we ask medical experts and user representative and technical experts to meet up. And then we do like sessions and we ask questions and we discuss about what could be done and what couldn't be done. And this is the first stage that you are right now. And then the second stage will be the pilot implementation and evaluation. So as I said, we'll have 3 pilot sites, one in Switzerland, one in France, and one in Poland. And then what we want to get from that is if it's usable, or if they use it, if it's like something that they come back again, and so on. And the last one, as we do this THCS initiative, they ask us to have a scale-up and dissemination, meaning that at the end of the project, the startup and the SME should take the lead on the products and be able to make money out of that. So where do we start from and what do we want to do? So the idea is that we would like to be agnostic from anything. So if you use a Pico, if you use like Meta, if you use whatever, we want to be able to do that with your headsets. And as well, we would like to be as well like agnostic from Unity or Unreal or other engine. So the idea is that we would like to do like some containers where we actually send and receive information through like network, TCP/IP protocol, and so on. So the idea is to make sure that everyone can access and everyone can build upon what we do like in this project. So as well, like Noah presented his PhD thesis yesterday, and his thesis is about how to assist therapists with a dashboard. And we present like information that makes sense to them because we have a lot of data. VR, we can actually have a lot of data, and you need to know which data is kind of meaningful for the patient as well for the therapist. So the idea of the PhD project is to work on that. And as well for like expandable models, as we know, AI is kind of obscure for now. So if we can make it less obscure, it's good. And we want to integrate solo, collective activity, and group sessions in the same environment. And the idea is we want to have this continuum of care between virtual and physical. That's kind of the idea of the project. The early result that we have right now, so we started the project in April like this year, so it's kind of a brand new project. So the early result that we have are more like on co-creation and co-design. And so we did a workshop in France with the medical and technical experts that are coming from different fields. So we have people that are coming from the older people kind of psychiatry sides. Some are coming from the ASD side as well. And the idea is to fill up like to do a list of what would be a success, what would be a failure in for criteria for each of the participants, like patient, caregiver, practitioner, health system, and companies. So because as we know, if we want to have something sustainable, we need to have a business model that goes with it. So we have 2 examples today of identified scenarios that we would like to address. So one for the junior, like the therapists that are following these people, they say that a lot of people don't go out of their home. So they don't go to the treatment, they don't go to the centers, they don't go anywhere because they don't want to be outside of their home. So with the headset and with Metaverse, I think that we could access this population that is really difficult to access. And then for the senior population, so we have a lot of seniors that are in the remote part of the countries, and it's difficult for them to go to the centers. So we hope that with giving them the headset or giving them the tools to go and to access the care system would be beneficial for them. So the idea is that we give them the headset for 1-2 weeks. We see how it goes with them. We kind of do like early detections, and if it's detected, we can say, okay, now we need to go for 1 session to the hospital, and then after the session at the hospital, we give them exercises to work on identified frailty. So the broader impact of our projects, the idea is to bridge home, clinics, and public spaces, because you can go to the hospital and then you can come back with your headset and you can do the exercise at home. It normalizes the mental health engagement, so it means that we can work on different levels on the mental health issues. And the idea as well of DHCS is to integrate it to national health system, and we need to have a business model that is sustainable for the companies, so the product is staying alive, because we know that idea is really great, but if there's no business, it's really difficult to get them on the long run. So the idea as well is to perform long-term prevention, and the idea is that I talked about 2 populations, but we could have much more population at the end, but we wanted to start somewhere. So we have experience in ASD as well as in older population, so this is why we actually chose those populations. So the conclusion of my talk is we think that immersive prevention is both feasible and impactful. I mean, we have the tool right now that we could do it. Now we need to see if we can actually find a business model that works, and we can sustain the development of such initiative. And for us, what we want to provide is inclusivity, scalability, and we would like as well, like we have a lot of clinicians that work with us just to make sure that what we do is meaningful. So this is the end of my talk. Thank you.
So hello, my name is Patricia Pons. I lead the Human-Computer Interaction Research Group at ITI, or Instituto Tecnológico de Informática, which is a private research center here in Spain, in the city of Valencia. And in this talk, I would like to show you the recent projects that we have conducted applying mixed reality to the mental health domain, and how we could work on providing more effective and personalized mental health care interventions that combine XR and AI. So we have seen a lot of successful deployments and applications of XR to different areas of health, from pain management to physical rehabilitation, medical training. And in recent years, we have seen an increased acknowledgement on the importance of mental health on general well-being of the population. So of course, we have seen an increased interest on applying XR for mental health care scenarios. And we can see examples of XR in mental health care applied to, for example, PTSD, exposure therapy, phobias, more recently to mindfulness and relaxation scenarios. But across all these tools, usually what we see is a lack of personalization of these environments in the same way or at the same level of personalization as a mental health professional would undertake. Because, for example, by that I mean we need to personalize these XR experiences to adapt to the user's emotional state in real time in the same way as a professional would do. Because, for example, if a patient enters a physical consultation one day and they are feeling with low energy, not willing to participate too much, or perhaps something happened very, very recently that affected their mood that day, the psychologist is able to see that and adapt that session to that specific mood and perhaps, I don't know, talk with them in a different way or perhaps do not cover very, very difficult or triggering things that day and wait for another day in which the session could go better if the patient is in a more motivated state. So this is where AI comes in as a very promising tool because AI-driven XR systems could allow us to create a more empathically intelligent XR systems that could adapt to these scenarios. So they could be tailored to each patient's need. And this is very important in mental health care because each patient's journey is going to be very, very different from one another. So this personalization is required. And we have seen that XR interventions for mental health care have usually focused on VR, but with the recent interest in mixed reality, we're starting to see different applications of mixed reality in this kind of settings, especially because it can be very useful for some target populations in which VR might not be the most preferred way of interaction. And by that I mean people who, for example, might need, in order to feel comfortable, they might need to see familiar faces around, or they might need to be in a familiar space surrounded by familiar objects that they know, or perhaps people who are very sensitive to visually induced motion sickness. With mixed reality, we can reduce this kind of dizziness for this kind of population. And mixed reality also has a very interesting feature that is by blending the physical and the virtual worlds, we can reduce this gap between what we actually practice in a simulated environment and the application of that knowledge or those skills into the real world, because we are actually seeing the real world with augmented experiences, but that allows us to reduce this cognitive gap between the virtual and the real environment. So based on that, we started 3 years ago to explore how mixed reality could be applied to mental health care. And we built Arcadia, which is a mixed reality platform comprised of different interactive and gamified therapeutic activities. The activities are usually focused on emotional regulation. We are now covering other aspects because the platform has been built in a modular way, so we can keep adding new features as we keep interacting with professionals and adding things that they might need. But in this way, we wanted to provide them with a tool that could be applied transversally to different mental health diagnoses, from anxiety to depression to bipolar disorder, by targeting core skills such as, for example, emotion identification or mindful attention. And we have gamified these activities in order to make this process more motivating for the user to target another problem of mental health care, which is the dropout rates of patients during their therapeutic process. And we have co-designed all these activities together with mental health professionals from different areas, from occupational therapy to clinical psychology, in order to cover the specific needs or how they would apply these kind of scenarios into their own daily practice. Some examples of the activities we have in Arcadia. One of the activities is focused on emotion identification. And the first step here is to ask the person to externalize a thought that they have. It could be a positive thought or an intrusive thought, depending on what they want to practice that day. And they externalize it by writing it directly in the air with their own hands. And then they have to label or tag this thought into the underneath emotion of that thought. And this is envisioned so that the patient has the headset and the therapist is besides guiding the interaction in these initial steps, and perhaps later on the patient can use it by themselves. But the idea is that we could, through this visual interaction, they could establish this relationship between the thoughts and the emotions that are underneath by tagging them with the different creatures that represent the basic emotions. Another activity that we have is focused on animal therapy, when we also include haptic interaction. So this facilitates animal therapy when we do not have the physical animal, because usually these sessions with the physical animal happen just once a week, twice in a week at most, and then people or parents or carers do not have the ability to practice all these interactions at home. So in this way, they could somehow kind of practice these routines at home as well. So in this activity, the user is going to have a table with different objects, and they can interact with the animal. They can select which kind of animal and which kind of object they want to interact with. And we also provide haptic feedback. So depending on the kind of interaction that you do and the kind of object that you grab, the haptic feedback that you feel on the hand is going to be different. And as I mentioned, this could be applied either to the occupational therapy domain in order to facilitate, for example, self-care routines or taking care of others, or either if we want to practice a more cognitive task, perhaps the therapist could guide the patient to, for example, focus on specific objects or objects of a specific color. So depending on what the therapist needs, they can apply the same tool to different scenarios. And as I mentioned, when we started building Arcadia, we were thinking on individual activities in which the therapist is outside of the experience and guiding the activity, but they are not participating with a mixed reality headset. But then the concept of the mental health metaverse started to emerge, and we have started to think about providing multi-user experiences, either for co-located experiences in which both the patient and the therapist are located together in the same physical space, and they can use each of them a mixed reality headset and see the same physical room and the same augmented scenario, or either for remote experiences in which the patient might be at home and the therapist might be at the clinic. So this year we have built this kind of remote and collaborative therapeutic scenario in which a therapist can call a patient remotely, and this is the same activity that you saw, the animal therapy one as an example. They can see each other's avatars and see their interactions in real time. So they can, for example, pinpoint one of the objects. They are hearing each other, so there's verbal communication in real time as well. And this is just one of the activities, but as I mentioned, we are also working on group therapy sessions in which, for example, the different patients could draw in the air their emotions or practice a specific emotional dysregulation strategy together with the therapist in the same room. So what happened during this activity is that we are currently finalizing the user study, and overall the motivation has been really high. But the therapist told us that at the second or third session, patients started to ask for something more, because the interaction is always kind of the same. So they needed, for example, more objects, more kind of interactions to do. And this is where personalization is really, really important in order to avoid this decrease in the novelty effect of the experience. So biofeedback could be a very interesting tool to provide this kind of personalization. For example, there have been examples such as Flowborn or DPR, which use respiration sensors or different kinds of ways of measuring the respiration patterns of the person in order to adapt visually the experience to the respiration patterns of the person. So we have also included biofeedback within our system in this form, which is what we have called an emotional avatar. So this creature here that can be personalized depending on what the patient selects. Here is a dragon, but it could be another kind of animal. It's meant to be an external representation of the inner state, of the emotional state of the person. So it mimics the breathing pattern of the user by using a wearable sensor, and it also changes its shape, color, and form depending on the heart rate. So it allows us to easily visualize how the biological signals of a specific emotion might feel in our body, how they represent and work visually with those concepts. So these kind of XR scenarios that adapt and respond to the user's emotional state could be really interesting to provide this kind of the degree of personalization that I was mentioning before, and not just the visual part. Here you can see, for example, an activity that changes the, so there are different flowers opening in the room as the user breathes in and breathes out. This would be the visual part, but for example, if we have AI systems that are capable of recognizing the emotion of the person, we could adapt the therapeutic intervention to many different things, such as adjusting the difficulty level to the mood of the day. As I mentioned before, if the patient today is in a very, very low mood or a very sad mood, perhaps we do not want to frustrate them by putting them into a very difficult or challenging experiences, because the next day they are not going to want to introduce themselves in the activity again. We can also modulate the visual complexity of the activity, for example, reduce, in this case, the number of flowers that appear to do not overstimulate the patient. adapt the behavior of the different creatures that appear on the scene. In another activity, we have different virtual creatures going around that can interact with the person and approach it or go away or have a more playful behavior, depending on the mood of the person, because we do not want to bother them. If you are not feeling today quite chatty, perhaps you do not want that virtual creature going around you and wanting to play with you all the time. And also, as I mentioned, we do not have to focus just on the visual part. We can also focus on the kind of sounds, for example, that the experience provides, or the kind of haptic feedback that we provide, depending on the mood of the person as well. So talking about, for example, the sounds, generative AI is also another interesting tool which could help us here to personalize these environments. We could use music generation to generate the ambient sounds of a specific relaxation scenario depending on the user's preferences in real time. Or, for example, we are currently working on generating personalized 3D scenarios that are adapted to the user's specific needs. For example, if you ask myself or my partner, which is our most preferred place to relax, for me it would be the beach, and a very specific beach here near Valencia, and for him it is a forest, and a very specific forest that resembles his childhood place where he was going on vacation. If we could, in real time, ask the person, describe to us what's your preferred space for relaxing, and they could describe this, and then the system could automatically generate this specific ambient. This would allow us to create very, very effective tools, and in a very, very rapid way that do not need adaptation. It does not need the therapist to know any development tools or configure anything in the system beforehand. It could happen smoothly within the activity. And also, it has been mentioned in several talks, conversational avatars, for example, that could be adapted to the emotion of the person, to the biofeedback of the user in real time, so change the kind of conversation, the kind of words that you use, the formality or informality of the situation depending on the user's needs. And we are currently working on, for example, providing guided meditations in this kind of immersive experiences in which the patient is the one who is going to guide what would be a relaxing scenario for them, how would be their preferred way of conducting this meditation activity. And also, personalization does not come only from the inner state of the person, but also from the outer context of the person. We have now different SDKs from Meta, from Google, or from different researchers that allow us to detect not only the room in which we are, the floors, the walls, the furniture, but also the specific objects that are in the room, so such as a bottle, some kind of food. So we could use these specific objects to mediate the interaction within the system as well. And we are now co-designing these kind of activities with the mental health professionals, where we are really open to any kind of ideas or suggestions if you want to provide some. But for example, we were thinking about activities in which a child's toy, their preferred toy, could become this emotional avatar that I mentioned before that was purely virtual, that could be transferred into this physical toy that they have. And when they use the mixed reality headset, this physical toy gets augmented. It becomes alive, and it guides the interaction. It becomes the protagonist of the interaction and guides them through the activity. So as a conclusion, these are all different works that we are currently conducting. But overall, what we want to explore is the capabilities of AI-based immersive experiences to create these engaging and personalized XR environments that are emotionally intelligent, in order to allow for this rapid generation of this kind of environments without requiring neither the user or the therapist to have a high degree of skills or learning curve to use them and apply them very easily, and also adapt not only to the internal but also to the external context of the user. So we are open to collaborations, as I mentioned. If you have any ideas on designing new scenarios or how this could be applied into some situations that you know, or also the validation of the different technologies that we have now, we are really eager to talk with you. Thank you very much.
Right, so welcome to my presentation. I'm Bernhard Spanlang, and I am the CTO at Kiin, which is a company that develops virtual reality experiences.
I don't think it's working. Yeah.
It's not working?
Oh, no.
Yeah.
All right.
Just need to move a bit to the... No.
Right. So basically this talk is about the platform that we've been developing over the last couple of years, and this platform is basically aiming to optimize creating experiences and measuring people's behavior in such experiences through randomized control trials. So what we're doing is we're addressing bias with this platform and also behavior change. And Kiin is the name of our company, which stands for the family, and we're aiming to basically help people to behave better.
So now we have many minutes for
Yeah,
Okay, so an overview of the presentation. I'm going to first talk about embodiment, just a little bit. Olaf has already mentioned yesterday quite a lot about that. Then I'm going to mention about the company, Kiin, and the defining experiences that have led to what we have developed now. A little bit about the architecture of this system that we've developed, and then I'm going to talk about some new experiences that we've made, especially in the Guest XR project, and then some summary and next steps. So it's all going back to the rubber hand illusion again, which Olaf has already mentioned quite a bit yesterday, and also there's been some discussions yesterday. So here another video about the rubber hand illusion, where you see on the left the rubber hand and on the right the hidden real hand. And there's a visual tactile correlation between them, and in the end there's a threat, and you can see that the participant here gets also scared, and this has a real impact on the participant. And just as a reminder, there is the homunculus in our brain, which is a representation of our body in the brain, and probably the rubber hand illusion works as well as it does, because the hands have a very big representation there. So we've been working for a long time on extending that, not just for rubber hands, but to real virtual reality bodies, whole bodies, which we can also induce this illusion, not by visuotactile correlation, but by visuomotor correlation. So basically, the participant, when they move their body, that movement is mapped to an avatar, and through that mapping, the participant starts to correlate that virtual body with their real body. And that shows that the brain is very plastic in adapting such illusions, or basically is very flexible in accepting a different body. So about the company, we are Kiin, the company which used to be called Virtual Bodyworks, is now called Kiin. It's been founded by Mel and Mavi and myself, and we're basically focusing on creating experiences in which people learn by experiencing rather than being taught something. So it's an implicit learning experience, and we call this learning by feeling now. And most of our experiences, they are based on the golden rule, which is something that has appeared in many religious texts over the last couple thousand years. And what it basically says is that we should not do to others what we would not like to have done to ourselves. And this has even appeared in ancient Egypt and all over the history. And what we do is, in virtual reality, we can, of course, create experiences where you can see your own behavior. So some people may not know what they are doing to others, and through our experiences, we're able to show them what they're doing to others by creating experiences where they see as a bystander or as a victim the situation from different perspectives. And the interesting thing is they can see their own behavior in these experiences after they've seen it from a different perspective. Usually in our experiences, we do test experiences like a couple of weeks later, where we check whether the first experience that they had an impact on these people. So we usually divide between experimental group and control group, and measure then 2 weeks later or a month later whether there's a difference between the experimental group or the control group. And usually we also show at the end how they could have behaved in a good way. So a couple of examples here. We've been doing a study with Google Jigsaw a couple of years ago where we trained police officers to behave well with dark-skinned suspects. We've been working for quite some time on domestic violence with the Generalitat of Catalunya. We've been doing work on racial bias. We've had a couple of experiences on corporate training, for example, where an employee experiences being where a dominant boss experiences being a young employee, for example, or experiences on sexual harassment or accent mockery, where, for example, a female employee doesn't speak the language natively and is being mocked by their colleagues. So here there are some examples where on the domestic violence, on the top right you see a person being embodied as a child. That would be usually someone, a violent offender who has been imprisoned for their offenses, and they are going through a training. On the bottom you see the same experience but from the perspective of a woman. So these are actually being used currently in training or in rehabilitation in prisons in Catalonia. And this image is on the accent mockery. So you are embodied as a black woman who doesn't speak the language well and is being made fun of by their colleagues. So we've been collaborating with quite a couple of companies, mainly with SLB currently, with National Health Service in the UK, Jigsaw, Google, and BNP Paribas, a bank, and Generalitat of Catalunya. So here's an example of what we've done in the Google Jigsaw one, for example, where participants first are in the bystander or as a colleague of a police officer on the left. And they are interrogating a victim, a dark-skinned victim. On the right, you see the same scenario played back where they see their own actions from the perspective of the dark-skinned participant, dark-skinned suspect, and on the bottom, the same scenario from the perspective from a third-person perspective of another police officer. So there are two groups. Either they are embodied as victim or they are embodied as another police officer. And then 2 weeks later, we run a test experience where they are exposed to an assault by a police officer, like they're an observer of an assault by a police officer, where a dark-skinned person is being attacked. And we could see that there's a very big difference between people that have been the victim in the interrogation compared to those that were police officers. So in our system, we usually collect body movement data. We could, for example, we can work out where people have been looking while they were in their experience. We also usually measure or capture their voice, so we know what they've been talking. In some experiences, that's important. And then we carry out aggregated statistics over control group or experimental group and compare those. And we usually also have questionnaires where we compare their conscious behavior, like what they've been answering in the questions, with behavior of body language or voice or where they looked and things like that. So this is pretty powerful in terms of analysis. We can very, very nicely play back what they did in these experiences and can then do analysis on those. So on the platform itself, so this is the overall architecture, which is obviously very simplified, but still pretty complex here. So this is based on Unity 2022-3 at the moment, and there are like the main components. There's the app here, and then on the top is the database, which is a cloud service which holds like people's accounts so they can log in, but also content like the actual environments or audio, avatars, and all that. But interestingly also, we can actually define a structure for running studies. So we can say this experience is being part of a study, and that's going to be executed at that and that time and is going to have this number of participants. So we can send out a link to these participants and they would be invited to the study. I'm going to go into more detail later on that. So what's interesting on the app itself is there's this state machine, which basically allows us to run what's happening in an experience. So the state machine can change what an avatar animates, for example, or how the environment changes, which sounds are played in the experience. And these commands that are executed in the state machine, they can also be executed by an external system, like a client that connects to this application from a PC, for example, that runs a Python script and that can control what's happening in that environment. The app itself can also be connected to another app, so there can be multiple people, up to 10 people meeting in such an environment, in different remote meetings in such environments. And we can also have a connection to a real-time AI interface. So we've been connecting, for example, to ChatGPT 4.0, which we can connect to an avatar and send a prompt to ChatGPT for telling ChatGPT how that avatar should behave. What's interesting here is we're using the real-time API, so there is very low latency. It's a speech-to-speech model. Basically, we're sending from the microphone the audio to ChatGPT and then getting audio back directly. So there's very low latency and we can have fairly natural conversations. And what's also interesting here is that this system can have access to the command system, which allows us to change aspects of the environment. So the AI, while you have a conversation, for example, can change the light of the room or can play sounds. So this is part of the prompts that we give to the AI. We can specify what the AI can do in the environment. So, for example, you could have a conversation with a therapist, and that therapist then not only can talk to you, but also can change the background music or the lighting to make it more adapted to the conversation. We've been testing with this, and currently this works a little bit more like Alexa, so you can say, turn the light red, and then the light's going to turn red. And it doesn't work so well yet with understanding people's emotions and changing the environment based on their emotions. So, yeah, there's a lot to this system. We've also got in the system built in the possibility to record people's body movements and voice, so which then can lead back to the analysis. And we deploy it through Meta Quest devices on the Meta App Store. Right. So there's some examples here of interaction between me and a friend of mine. So here we have like facial expressions mapped in real time on both people using the Meta Quest Pro headset, which has cameras built in, you see on the bottom here. So it can be quite natural interactions between people through facial expressions and body language. We track hands, and those are mapped in real time. And what's interesting in the system, we can have these bodies be very different to the shape of the real body. So here there is one person embodied as a child and the other one as an adult. And this can be quite impactful. And the system is even capable of changing those body shapes in real time gradually. So you can become a child gradually or become an obese person or whatever body change can be done. So in order to create content for our system, we usually interview our clients to understand what they need for their employees to go through. We then run prototypes with AI. So we basically generate the scripts with AI, but we found that this is actually not working quite as well as it sounds it should be, but we still need usually human script writers that help with AI prototypes and then refine those. And also the same with text-to-speech systems that generate the audio. We've had some good experience with those, but we still find that human actors perform better and more more engaging. Yeah, then for the content creation, we create environments, we place avatar anchors, and then we basically use the system itself to create the content by capturing people's body movements, and then we describe what's happening in the experience, who is embodied in which body, and who's playing which animation, and things like that. And these experiences are then refined and iterated to be improved. As I mentioned before, the system also supports running studies pretty much automatically, so we basically have a functionality to...
Just finish.
Functionality to send out links to invite people to participate in a study, and they can then choose the time and date when they participate. The system then sends back to them a code, which when they go to the experience, they enter that code, so we can anonymously track people's behavior change over time. So currently they enter this code by hand, and we're currently working on using QR codes to make this step easier as well. We've got quite a few experiences, one on eating disorders, several self-conversation experiences, co-presence study that Bea mentioned yesterday, an EEG study, a climate change study, audio haptics, which is a study on helping people understand better in noisy environments, or to find whether that's possible. Then historic protest events that we've been doing in the Guest Excel project, and then there are several large language model agent systems that or experiences that we've been building, and we're constantly building experiences for corporations. So here, the self-conversation that has been mentioned also by Doron yesterday already. So where you first embodied as yourself and then embodied as a therapist, and there are many variations of that, and this has been very successful in many studies and published several times. Then the EEG study that Bea already mentioned yesterday, where we are basically interested in the difference between being with someone or being alone or being with an avatar. That's basically participants' brain activity is being captured while they are doing this image recognition task, while different sounds are played. So we've been capturing quite a lot of data of 40 participants with that, and this is being analyzed at the moment. And then there's the climate change study, which we're doing in collaboration with Warsaw University, where there are people meeting. Well, there are usually 3 people, and they are in a tragedy of the commons problem where there is a limited resource in this middle, the cubes, which people are competing for, and they are learning that the more they compete, that the more wealth they gain, and by that competition, they are also polluting the environment, so they see a direct impact on the environment while they are competing. So the goal of this game is to find an equilibrium between competition and collaboration to pollute the environment little, and everyone still can have some gains. This has been run with 20 participants at the moment, but they're still ongoing. And finally, we've been collaborating with Norway University, where we're basically reconstructing an historic protests. The left one is a protest on abortion rights in Warsaw, and the right one is on pro-democracy rights in Hong Kong. And basically what we're trying to do here is have a reinforcement learning system that tries to get people participate within the protest. And so this has been run with 60 participants. I'm not sure if it was very successful. I think we may have had some issues with the actions that the agent performs, but we're currently analyzing that data. Right, so that concludes my talk. So basically we're building a system that allows us to run studies more efficiently and create experiences efficiently. We are aiming to make those more performant still. There's always work on that, and still streamlining the deployments, automating with AI the content, and to automate also the analysis of these experiences or the behavior of people. And finally, we would like to make this available to everyone so that people can create their own content. That concludes my talk. Thank you very much.
Thank you so much. Thank you so much to the three of you. I think it's amazing to see all these systems actually and how they relate to each other and how they provide various different aspects. So we had a question some time ago, so maybe we can go to that question first. There was a question there? Yes. I don't know what to do with the microphone. I can start moving, actually. It's good for my health, so. Can you? Yeah, great. And maybe you can change the order of the names. So people have your actual name in front of you.
Hi, hello. So my question was quite easy. So what do you mean, this is for the first presenter, what do you mean by hybrid model care? You can explain something, the idea about what is it and how this works?
What is the what?
Hybrid.
You mentioned that you create hybrid model care, as I saw in presentation. So
Yes.
yeah.
So the idea is just that we want to have the home as well as the care space. So the idea is that we want to have this continuum of care that goes from the hospital into the home and the practitioner. So the idea is that we want to have an hybrid version of care in the fact that we have hospitals and then we go to the practitioner and then we go at home. So the idea is that we want to have like a seamless kind of experience for the patient. So he can have his or her treatment wherever he is.
There's another question there. So if you have a question, just raise your hand and we try to do. We are going to take only 5 minutes, but.
Yes, thank you so much for the wonderful talk, very insightful and very advanced. I have a question for Patricia. Do you have any insight on the difference or valuability of having the therapy in a group compared to a personal session? We have similar projects, and I've been always asking myself these questions. Is it worthwhile moving from personal one-on-one in VR to group sessions?
Yeah, actually that project we have just started, and that's our discussion right now. Which kind of activities even should be even individual? Because there are some, so this is focused on people with eating disorders, and there are some parts of the activities in which they have to identify triggering situations for them, and perhaps that's a lot of personal stuff in there that might not be easy to get out in even with in a VR setting in which you do not see the others around, but you know they are there. So we are still deciding which parts are going to be individual or practice with the therapist alone in another session, and then which parts made sense as a group therapy, because the professionals think that there are some kind of interactions that could emerge in those. For example, the part on emotion identification based on these triggering situations that each of them has identified previously, so you do not know which person has raised these triggering situations, so it's kind of anonymous. But then they might be, there might be commonalities. Then they have this part of emotion identification, then drawing these emotions, and they want to see if there are some patterns, and they thought that this part could be interesting to allow people to see that perhaps other individuals are feeling the same in the same way in their body, or reflect like this kind of group experience. And yeah, but we are still deciding which parts are going to be better as an individual activity or as a multi-user experience. So yeah, really eager to know as well what's your thoughts on that. Yeah.
Okay, so first of all, here. Yes, here. Thank you for your talks, and my question was also to Patricia. I'm not sure if you mentioned something about diagnosis in all this like VR world. My question was about how you perform this diagnosis, or how you can.
Actually, we do. Perhaps I don't know, I overtalk and say diagnosis, but it's not something that we cover. We usually are the same as Anthony on the second and third phase, so trying to reduce the symptoms and have some kind of management and avoid difficulties, but not on the. What we want to do is emotion recognition, so not a diagnosis on a specific mental health disorder, but rather emotion recognition.
Okay. And have you, have you like some explainability methods for the AI models that you can use inside these worlds, or it's something that you don't cover?
We actually started with the same discussion that was raised yesterday about the two-dimensional model on emotions, and then we thought that that might be some kind of limited for the kind of things we wanted to do, and we are now exploring different devices, especially because with biofeedback. So we wanted to do it with just with biofeedback from the user, and currently we were using heart rate, respiration, electrodermal activity, and this year we started to introduce EEG as well. And we are still getting to know how you could use EEG in a real environment. So we do not want the person to be static. We want them to perform these kind of activities in which they move around. So we are still in the process of knowing which kind of ML models should work well for that. Thanks.
Thank you for the nice presentations, and you all have application using a lot of data from real patients, by the way. So my question to all of you, but maybe Bernhard, because you have actual clients, and the other two they are research projects. How do you address privacy and cybersecurity concern in the design phase?
Well, yeah, I mean, I mentioned we are trying to be anonymous, like having our participants anonymous. We have a data management plan. So we have like in place that this data is going to be deleted after a certain amount of time. And there's encryption on the device, on the transfer, and at rest in the cloud. But yeah, I mean, there are definitely concerns regarding privacy. I mean, we usually have a contract with companies, so we only do these uploads if there is a signed contract where people agree that this is happening. We're not gonna, I mean, all these uploads are optional, obviously. So if a client doesn't want any analysis, then we can turn these off.
Anyone else wants to answer?
Maybe I can. So for us, we are taking privacy like by design, and the thing is that we are, as you said, we are designing the project right now, or the product. So we would like to have anonymization of the data, giving like a number to a patient, so we cannot trace back the patient with the data, and so on. So pseudo anonymization as well as encryption, end-to-end encryption for that. So I think that for us, it will be a huge aspect of the project as well, to make sure that all the data that we get is safe and follow the GDPR protocol and so on. So we put a lot of effort on that.
And if I may add, there's another layer in our case that has raised us some questions as well. As we are using biofeedback, we usually want to do it with wearable sensors. We do not fabricate these sensors, so we tend to buy commercial devices, and then those devices have proprietary cloud services. There's no access to raw data, and you have a lot of problems there because we do not want this data, which is privacy for the users, to go into some server in a place where you do not control these kind of aspects. And we have struggled a lot trying to find the appropriate sensor fabricators or hardware devices that suit us for this purpose, having in mind that at some point we have to deal with this kind of stuff.
Aurelio,
yes, I'm sorry because we are out of time, but I would like to be a little bit more precise on that question that Serena has asked. And the question would be, do you have a legal expert helping you at the designs of that applications? I mean, helping you to comply with all the legal requirements? For instance, the AI Act has not been mentioned, and you are playing with emotions. Okay? That's the precise question. Is yes or no? And I'm not blaming you for not having a legal expert.
We don't have legal expert, we have ethical experts. We have an ethical expert. I mean, we don't have a legal expert in the group, but we have an ethical expert that actually tell us what we could do and we shouldn't do. But we don't have a legal.
Well, we have ISO standard consultants, so they know their stuff, but they're not lawyers.
And for us, it's quite similar. We do not have a legal expert at the team, but we have experts in the AI Act at the company that can assist us in this. But I think it would be very, very important to have collaboration with legal experts just for the specific applications at initial stages for the design. Yeah.
That's great. Eh?
So with Aurelio getting 3 new projects, then go for the break now. Thank you very, very much.
Thank you.
And,